Hello, everybody. This is my research on AI-generated music composition. My name is Kunal Vinayak. My mentor is Lucy Werner. I'm a sophomore at American High School in Fremont, California. Um, Music is my passion and my preferred form of expression. It resonates with the core of my being, providing solace and inspiration. In every beat and melody, I find myself. My father used to play Yanni Strong in a loop. The exhilarating crescendo music stirred me. I found out it was based on Antonio Vivaldi's Violin Concerto, Summer. This became my love for the classical music. I went to my middle school counselor to beg to let me take the orchestra class where I picked up my first violin. Uh, the music of Tchaikovsky, Mahler, and Dvorak became my best friends. And I started composition and tried to recreate the sounds of the notes in paper and then in a music composition software, NoFlight. I began to learn how other musical instruments to recreate the sounds I love. And I wanted to take music into its next evolutionary phase. I wanted to build robots that could play musical instruments. I wanted to use AI to enhance the human creative process to combine past music, feel, genre, rhythm, harmony, and speed to orchestrate unique music. The use case of my AI composer stems from the process of composition itself. When composers create a piece of music, they typically follow two steps. Firstly, they craft the melody, and secondly, they incorporate background music in order to enhance the melody. The AI composer contributes to the efficiency of melody creation. As a composer myself, I often lack inspiration to start a melody. The AI composer helped me by making the initial melody for me. I then build upon and make the melody sound better. This not only kickstarts and streamlines the compositional process, but also allows human composers to infuse the composition with emotion and ensure its overall quality. Rhythm is the length of notes in a piece. Actually, first of all, I'll give you some context on music theory so you can understand my project. Rhythm is the length of notes in a piece. Composers use patterns of short notes and long notes in order to create an interesting sound. Classical composers often use short to medium length notes to create tension in a piece and longer notes in order to resolve that tension. Long notes include half notes, whole notes, which are the big circle on the picture on the left side of the screen, and the note with a stem with a hole in the middle. Short notes include quarter, eighth, and 16th notes, which are the bottom three lines in the left side of the composition. Patterns of rhythms are what create good songs in composition. The picture on the right side of the screen include common patterns that composers use. Another concept of music theory is pitch. Pitch is the perceived highness and lowness of the sound. The pitch of a note is presented on the musical staff by how high it is. For example, in Twinkle Twinkle Little Star, the higher notes are presented on the middle of the staff, while the lower notes are presented below the staff. In songs with multiple parts, the background music is lower pitched than the melody because higher pitched sounds stand out. And another concept is intervals. Intervals are the difference between two pitches. Low intervals indicate that pitches are close together, while high intervals indicate that pitches are far apart. Intervals are very important in making the music sound good. Intervals either add tension or release tension. Small intervals create lower tension and resolution, while higher intervals create lots of tension and reduce tension greatly. Good compositions are built on increasing tension, and then releasing that tension in order to tell a story. Another concept of music theory is key signatures and scales. Key signatures and scales are large connections of notes that sound good together. Every key signature and scale all sound the same intervallically, but are higher and lower in pitch. They're sort of like languages. When you say a sentence in French and then in English, they both will mean the same thing, but will have different vocabulary and grammar. Transposition or modulation between key signature is like translating between French and English. This is done by lowering or raising the pitch to another key while keeping all the intervals the same. This makes the music sound the exact same, but either higher or lower. This is the methodology of my model. To generate a melody of specified length and tempo, the process initiates by extracting a list of notes from MIDI files, which are like sound files from a database. These notes are then converted into intervals and previous intervals in order to capture sequential relationships. By analyzing the data set, probabilities for each interval's occurrence, considering previous intervals, are computed. Using these probabilities, these notes are selected to compose the melody. Subsequently, a MIDI file is generated, incorporating the chosen notes to produce the melody, adhering to a specific tempo. This process facilitates the automated creation of melodies based on learned patterns from MIDI data, offering a systematic approach to music generation tailored to user-defined parameters. The research methodology centers on extracting musical patterns from existing composition. These compositions are sourced from a data set of 118 songs featuring classical composers such as Tchaikovsky, Bartok, and other classical composers. They are all stored in a musical instrument digital interface file format, MIDI. I coded the 118 songs into the computer by looping through the database folder and putting all of the song names in a list. That way, if I want to contact any song from the database, I can just use the list. The composer then extracts notes from the MIDI file, creating a comprehensive list of all the notes used in the piece. MIDI acts as an intermediary between sounds files and code. Python leverages packages like MIDI util and MIDO that can facilitate note extraction from the songs. Due to the large scale of notes from the 118 songs, the list from the previous step comes in handy. The algorithm loops through the list while accessing each song and storing all of its notes. The subsequent step involves determining the probability of different notes and composing a melody. The complexity of varying key signatures poses a challenge, so two solutions are proposed. Transposing all of the key signatures to one and then composing the piece, or just using intervals. I chose intervals due to its simplicity. In order to create an intelligent melody, the probability of the composer choosing an interval is dependent on the context of the note. So for example, if I go from two notes, C to D, that is the most probable choice. But if the note before C is G, then the next probable note would be E. This allows the AI composer to create patterns in the music. Then the list of all notes is then converted into two more lists, intervals and preceding intervals. These two lists form a NumPy array of probabilities. These probabilities are then used to compose the melody and converted into a MIDI file. Here is the example composition from the AI. Oh, sorry, 1 second.
Not hearing it.
You cannot hear it? Okay.
Fortunately, no.
Okay, that is a problem. That's fine then. I'll just show you the sheet music. The notes are the intervals use jumps to create tension, like over here. And as the piece goes along, it is in a stepwise motion, and at the end, it uses big jumps to resolve. I created an entire composition based on the AI melody in order to fulfill its original use case. Can you tell me if you hear this one?
Unfortunately, no.
No? Okay. Now the next steps for this AI is to scale the AI to go for 1,000 files in 1 second and efficient sizes with the help of a GPU instead of just 182 files to create one melody in 5 seconds. Right now, the genre is in classical music, but I want to expand the number of genres. In the future, I also want to create AI-driven personalized video game music, AI-driven personalized music therapy, and AI-driven music theory education. The successful integration of artificial intelligence into the efficiency of music composition, which is the 4 times speed, while creating the composition, meaning that it took 4 times less time with the help of AI to create the same amount of music than with no AI. Any questions?
If you wanted to drop a link to those sound files in the chat, that way folks can listen to them, because I feel like that it would be great if we were able to listen to them since we weren't able to see them as part of the presentation. One question that came in was, are there any defining characteristics to recognize an AI generated score? And would a fully AI generated score feel less inspired?
Yes, to both of those questions. That is why there are 2 people or 2 things that contribute to the composition, the AI and then the human composer. Let me go back to the previous slides with the, so over here, you can see that the entire melody sounds like just a repeated pattern, correct? So the AI, a lot of melodies are created based on patterns, but it is very helpful to also include variation in the patterns in order to create, because it'll get just, if you repeat the same thing over and over again, it'll get boring after a while. So the AI melody does not have the skill to tell whether the music is getting boring and there needs to be some variation. That is why the AI composer needs the help of the human composer in order to change up the thing. So over here, I changed the melody in order, I changed the melody in order to create more interesting sound. And at the end, I changed the melody to create a more interesting sound. And the human composer is also definitely needed in order to harmonize the sound. I will drop the links below and then you can see the difference, because it's really, you can hear the difference between the AI and the human helped composition.
Awesome.
Okay.
Thank you so much.